What we have on this one is same kind of thing. We're solving a rational equation. The one difference between this example and the last one is now we have multiple radicals. So what Bob says, the textbook publisher here, he says we need to isolate our radical first. So I'm going to move this one to the other side. The reason I picked this one is just because it's has a nice little negative coefficient, so I can add it to both sides. I always like working with positive numbers better. And that's going to give me the square root of 3x plus 1 is equal to the square root of x plus 4 and then plus 1. Now, no matter what, we're not going to be able to just get a monomial on each side. So, yeah, we're just going to have to play the hand we're dealt here. But now that I have one of my radicals isolated, I'm going to go ahead and square both sides. When you square this side right here, it works out real nice for us. We get 3x minus 1. However, when you square the other side, what you're going to need to do is it's a binomial, so we can't just square each term. What I'll need to do is basically multiply it by itself. So when I do this, what I should get, the square root of x plus 4 times the square root of x plus 4 is going to be x plus 4. This times this will give me the square root of x plus 4. This times this will also give me the square root of x plus 4. When I add those two things together, I'll get the square root of x plus 4 with a coefficient of 2. And then 1 times 1 will give me 1. So when you square that radical, that's what it looks like. Now what we're going to do is we're going to try to isolate our radical again. So unfortunately, when you have multiple radicals, a lot of times you'll have to square your problem more than once. So I'm going to go ahead and subtract x, subtract 4, and subtract 1. So minus x here, I'm just going to put minus 5 because when you subtract 4 and 1, that's the same thing. So when I do that, I'll get 2x, and then minus 6 is equal to 2 square root of x plus 4. Now at this point in time, I could go ahead and square both sides of my equation. If I were to square this, it would give me 4 parentheses x plus 4. And then I would have to square this side too, but I always like working with smaller numbers. And what I see is there's a 2 here, so I'm going to go ahead and divide everything by 2. Now, if both of these weren't even, then I wouldn't do that. If this was a 3, I wouldn't divide this and end up with a fraction. I would just square both sides and deal with it from there. But I see that that's a common factor, so I'm going to go ahead and divide everything. So I get x minus 3 is equal to the square root of x plus 4. And then next what I'm going to do is, since I have my radical isolated, I'm going to go ahead and square both sides. Remembering that when you square this binomial, you're going to write it twice, so x minus 3 times x minus 3. When I do that, I'll get x squared minus 6x plus 9 is equal to, when you square the radical, it's just going to cancel. As you can see, we have a quadratic equation, so what I'm going to do at this point is go ahead and get my variable, or everything on one side and set it equal to 0. When I do that, I'll subtract x from both sides, so that'll give me negative 7x, and then I will subtract 4. So let's see, a positive 5. Did I do that right? I'm going to make sure. Subtract 4. I think hopefully I did it right, maybe not. Let's see, I'll check. After looking through my problem, as you can see, man, that just doesn't look factorable to me. So I'm going to go back and check my work. As I go back, I look, I see, okay, I isolated my radical, I squared both sides, but then I copied my problem down wrong. So yeah, fun stuff about math. Make sure that you're doing your math correctly. Here, when I squared this radical, for some reason I put a minus instead of a plus. So that's obviously going to change my problem. That's going to come in here and make this now a negative 4. It's still divisible by 2, so that's good. That's going to make this, instead of being this, that number's going to change now to negative 2. And then, of course, it's going to change all this other stuff. So, you know, whenever you're doing your math problem, make sure that you're aware of what you're doing and also checking your answer. Go back and just look at your work sometimes, because as you can see, I have completely messed up this problem. So let's see if I can't finish it. I'm squaring this binomial right here. So when I do that, I will get a negative 2, or x, that'll be negative 4x plus 4. Now when I go ahead and subtract those things, hopefully it'll work out a little bit better for me. I get negative 5x, and then the 4's will actually cancel. Sorry about that, but it happens. We're not perfect. Even teachers make mistakes. So don't be afraid to make mistakes in your problem. Just go back and look and recheck your work. Once I factor out the common factor of x, I can set both those equal to 0. So the solutions I will find, when I set this equal to 0, I get x equal to 0. When I set the other term equal to 0, I'll get 5. I do need to check my answer. When I plug in 1, this will give me the square root of 1, which is 1. Over here, it'll give me the square root of 4, which is 4. 1 minus 4, unfortunately, is not, or I guess it would be 1 minus 2 after I take the square root of both sides. So that's the square root of this, square root of that. Those will not work because this will be 1 minus 2 is not that. So we are going to call that an extraneous solution. And then I'm going to plug in the 5. When I plug in the 5, this is going to give me the square root of 16 here. Over here, it's going to give me the square root of 1. So, square root of 9, rather. Man, I had a rough day today. Square root of 16 is 4, minus the square root of 9 is 3, so that should give me 1. So that is my one and only solution that will work for this one.